Hi everyone. So I'm Kshetrapal, part of Azure Postgres team at Microsoft. So my session would be the last one today. I hope everyone is not going to feel bored with this session. So my talk is about the PostgreSQL security and what are the features those got introduced between the version 10 to 17. So coming to the agenda, I have divided today's talk into I would say like uh, two entities. The first one is about the user management, roles and privileges, and the second one is about authentication and security. So under user management, I would be talking about the public role and public schema, and what are the best practices of public role and public schema, and what are the changes happen to the public schema when compared to the different versions of Postgres. And then I would talk about the column level security, how to grant permissions on a particular table column. And then I would talk about the improved role management, how the role management inheritance especially has improved across different Postgres versions. And when coming to the authentication and security, like I would talk about the password authentication mechanism, that is SCRAM SHA 256, and how it is beneficial compared to the MD5. And I would talk about the different authentication mechanisms such as LDAP authentication, GSSAPI, which uses the Kerberos tickets. And then I would also like touch base on enhanced password policies, like we can mention the password expiry date, right? So such kind of things. And then I would talk about the direct TLS handshake. So I will be not covering entire TLS. So there is a mechanism in recent Postgres 17 version, so that allows us to do the direct tailless handshake that improves the connection performance. And then obviously incremental backup support, it indirectly improves the security of our database. So yeah, user management, right? So I would talk about the public role in this slide. In the next slide, I would touch base on the public schema. So how many of you are aware of public role and public schema? Can you raise your hands? Both public role also? Schema. I think most of you are aware of public schema, right? Okay. So what is so before explaining about public role and public schema, okay? So I would like to explain how these two entities gets created in Postgres, okay? So whenever let us assume like you are installing the Postgres from the sources, okay? So once you do the initial compilation, you need to initialize the database, right? Whenever you do the like initialization of the database, there are three databases gets created by default. Okay, those are template 0, template 1, and the Postgres. Okay, so these public role and the public schema, they are automatically part of this initdb process. So that is the reason you can't see, like if you execute any query such as /du or select star from, there is a catalog table which shows these users, like only the users created by us. But you can't see the public role from that PG, either from PG auth ID or from /du. So basically /du at the back end, it queries the PG auth ID and shows us the output. Okay. So and again public role, right? Public role, like by default, it is available. It's public. Okay. So it is available to all the users. I would say rather public as the group. Okay. So suppose you install the Postgres cluster, you created a database, right? And you are trying to create a new user. Whenever you create a user, this public role or group, it automatically gets assigned to the new user. Okay, and also like public role, it automatically gets three types of privileges. Okay, so the first one is the connect privilege. Connect privilege is nothing but it allows us to connect to the database. Okay, and it also like allows us to create the temporary tables, public role. So like when I say the public role, let us assume it is similar to like whenever you create a new user, it automatically gets all these privileges. Okay, and also like public role, it gives us the usage privilege on the public schema. Okay, public is a role and the schema also. Okay, so and also like this is the important point. Can the public role create the objects in public schema? Can someone answer this question? Can public, so that is partially true, that is not true in all the versions. Okay, so like I will come in the next slides about it. Like until Postgres version 14, public role allows us to create the objects in public schema. However, from the version 15 onwards, we can create any objects in the public schema. This is specific to only public schema. Okay, so as I said, if you see, I have given du there and I can't see the public role there because it gets created during the initialization of the database. That is the reason by default. So like now I would like to focus on the public schema security. So like in version less than 15, that means like I mean until the version 14, what is the behavior? So as I said, this like public schema, it is a default schema, and when you see the search path by default, right, it is public always. Whenever you try to create any table or query any table without mentioning the schema, by default it go and search in that search path. If it is public, then you try to search in the default schema. So what is the risk, right? So until version 14, public schema allows all the users to create the objects. I mean the public role in the within the public schema. So whenever you just create a user, and it does not matter whether you assign any privileges or not. Without any privileges also, public role for any newly created user, it allows that particular user to create the objects in public schema. So this is a security risk because anyone can go and create the objects, right? Let us assume like if it is a productive database, right? So it's a risky thing. So as I said, like in multi-environment, like this can lead to unauthorized changes also, right? Because they have all the accesses on public schema. So here I would like to explain this with a example. So there are predefined functions available in Postgres to check whether a particular role has the required privilege on the particular database or the particular schema. If you see here, I have a public role and the Postgres database and the connect privilege. So it is returning true. If you see here in less than 15, I am getting true for all these functions. So the first function is has database privilege for so public is the user. Is my public role has the connect privilege on the Postgres database? It is returning true. Like that, is the public role has the usage privilege on public schema? It is that is also returning true. So this is happening for both the public role, and on the right side I have the normal user. I have encircled that with red color. So normal user. So in this case, I haven't shown this in this slide, but I just created the normal user, create user normal user with password. I just created it. And if you see, this is proving that that particular normal user has got all these privileges. Connect privilege on the database, usage privilege, and the usage privilege on the schema, and also the create privilege on the schema. And have a look at the, especially the third function has schema privilege for create, has schema privilege function for create privilege. So it is returning true for the versions which are less than 15. So I have clearly mentioned that there is a 14 point, so the server is of 14.19 version. So it is returning all truths. So in the next slide, I will explain about like how does the public schema security change from version 15. See, from the version 15 onwards, so the public role by default gets usage and the connect and the usage privilege. But from the 15 onwards, the create on schema got revoked or like by default from the public schema. So I would show that in the next slide. If you see here, the first and second functions are returning true. However, the third one is returning false. So, and this is of version 15.14. So this proves that from version 15 onwards, so any user, unless the permission, unless the privileges are explicitly granted, they can't create any new objects in the public schema. So as I said, like I created a normal user and there are no permissions, no privileges assigned to it. If you see here the 14.19 which I marked in green, it allowed me to create a table in the public schema. So public.sample. However, if I tried that on 15.14, right, version 15, it gave me the permission error. So yeah, yes. So these are some of the practices on public schema role. So before explaining this slide, so in Postgres we can segregate the database security into the different levels. So the security at the database level, security at the schema level, and also the security at the database objects level. Okay. So whenever any client user want to access any database object, first of all they should get a database privilege which is connect. First of all they should be able to connect to the database, then they should get a usage privilege. This is like a 3-layer security. So once you get the usage privilege, then one should grant the object permissions to that particular user. I mean the DDL and the DML permissions, select, insert, update, delete, such kind of permissions. So irrespective of your version, like it is always better to follow these best practices. So whenever you have installed the database, just revoke the create on schema permission from the public role for the public schema. So for the 15 this is not required because this first one is automatically revoked by default, and this revoke usage on schema irrespective of the versions, every new user get this usage privilege on the schema. So revoke this usage privilege from the public role for the public schema, and same goes with connect on database as well. Okay. So any questions so far about public role and security? Yeah. So whenever you create a new user, automatically the public group gets assigned to that user. Yeah. Suppose you added a new privilege to public. So assume that that is available to all the users which are assigned to that public role. Yeah. Yeah. They can connect. They can still connect. Yes. Yeah. 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 So coming to the column level security, so this feature is introduced in version 15. So using the column level security, like you can grant the users the access to the particular columns of the database table. So I have presented a use case over here, like suppose you have the medical care facility where doctors, nurses and billing staff, right? If you see the billing staff is not supposed to see the critical information, only doctors should be able to see that. So like this we can assign different column permissions to the different users for a single table. From 15 version 15 onwards, one can use this column level security. And improved role management. So actually the role inheritance got introduced in the version 16 itself. However, in version 17 they introduced some functions. So I don't remember the exact function name, but if you give the role as the input to that function and execute it, it shows that chain, like how does the role inheritance happen from that role to the whatever the final user that is present in that inheritance chain. Okay, so this is pretty much basic. So yeah, so like whenever any user has the more permissions, right? Suppose in this case, if you see, we have a read user, a write user, and the admin, right? So I have assigned the application user to all these users so that they can get the inherit permissions from the parent user. So coming to authentication and encryption, can I know like how many of you are still using plain text or the MD5 passwords? You are using MD5. So and also like how many of you are using MD5 along with PG bouncer? Okay, you are using PG bouncer along with MD5. Okay. So this SCRAM SHA-256, so this is a new authentication mechanism that is introduced in version 10, but is not default until 14. But from 14 onwards, this SHA-256 is the default encryption algorithm. So like in configuration file, there is a parameter, you need to set this so that this particular authentication mechanism gets activated on the cluster. So here if you see like what is the difference between SCRAM SHA-256 and the MD5. So in MD5 what happens whenever so let us assume like all your passwords are compatible with MD5, your authentication mechanism is MD5. So whenever client enters the password, so right, so that password whenever the password gets created, that password gets stored in the form of MD5 hash on the database. Okay, so here in MD5 the password hashing is done at the server level, whereas in SCRAM to SHA-256 the password hashing is done at the client level. So that's how it is safer when compared to MD5, because my password is not being transmitted across the network. So even before transmitting, like I'm hashing my password at the client level only in case of SHA-256. So I have mentioned the PG underscore HBA conf file here. So pretty much basic. So for MD5 you need to mention MD5. So for SCRAM you need to mention this. So, and if you want to change the password encryption to MD5, sorry, to SCRAM SHA-256, you need to mention that parameter and then create the role. So from that instance onwards, all the new passwords gets created with SHA-256 algorithm. So LDAP authentication improvements. So LDAP has been like Postgres has been supporting LDAP since the initial versions. However, in 11 there is a support to do the LDAP or the SSL. So this is the content, like this is the text you need to place in PG underscore HPA dot host based authentication file to enable this LDAP over SSL feature. Okay, and then GSS API encryption. So this is pretty much similar to the LDAP. However, here the user authentication is done via the Kerberos realm. Kerberos realm is nothing but a nothing but a AD server where all these user passwords get stored in the cryptographic form. Okay, and also if you see I have mentioned here, so this GSS API authentication happens via the Kerberos tickets. So there is a Kerberos ticket like request and responses, and then token gets exchanged between the client and server, and the secure context gets established between them, and then the data transfer gets initiated. So enhanced password policies. So usually like from version 13 onwards, so we can mention valid until. So this looks simple, but this is really important because it's better to like monitor the user expiry dates, and it's always recommended to prefer some expiry date for the users. and monitor those usages like quarterly or monthly wise. Okay, and also like we can use Postgres provides one credit check extension using which you can define multiple you can prevent using of multiple reuse of passwords, and you can enforce the password to have the combination of uppercase, lowercase, and the special characters. And you can do all such kind of things with the credit check extension. And the yeah. So next, I would like to go through some of the TLS security features from version 10 to 17. So if you see here in version 10, so the basic TLS support started. So using the certificates, we basically for example, we created the certificates through OpenSSL and we put those under the configuration parameters, and like we configure the PGHPA to allow the SSL connections and the mix of plain and SSL connections, right? And also, yeah, so this support has started in 10, version 10. So where like it used to support TLS 1.1 and 1.2. So between 11 to 13, there are new two parameters introduced where you can enforce the database to use a particular TLS version. So you can mention minimum and maximum TLS protocol versions. And also like in version 14, there is a complete support for TLS 1.3, and which is much more matured than the earlier 1.1 and 1.2 versions. See, in version 17, like I would like to focus on the version 17, like where the direct SSL negotiation is introduced. So yeah, so this is about the TLS handshake. So in the normal TLS handshake, what happens? Okay, so the clients sends a hello, okay, and then hello means like it asks the server like, do you support the SSL certificates? Then the server, what it does, it checks whether that SSL mode is set to on or not. If it is set to on, it says client, yeah, I support SSL. And then what happens? The server provides that server certificate to the client, because client need to validate the server identity, right? Either that particular server certificate, it can be the self-signed certificate, or it should be signed by the CA, certified authority. In productive environments, always the certificates should be certified by the CA, so that the clients can trust and do the authentications with the server. So once the server certificate is present to the client, what client does, it establishes session key, it establishes session along with the session key, and it encrypts that session key, and it send it to the server. So server usually have the private key, right? So it decrypts that session key using this private key, and its server also makes sure that yes, my request is coming from the client, particular client or not. So that's how the authentication mechanism happens in normal TLS handshake. So in direct TLS handshake, what happens, right? So the first two ones, client hello and server hello, we can avoid it. So that's how the initial connection establishment, right? We can reduce that turnaround time between the client and server if you use the direct TLS handshake. So you might have get a doubt, right? Like, so you are like the first client hello and server hello, those are the plain text exchanges, communications. But here these are TLS, these are just the hello messages. It won't send any confidential information using the first two messages. Okay. So incremental backup support, so it indirectly provides the security to us, because we can't restore the incremental backup without the reference based backup. Okay, and also like we can take the frequent backups using the incremental backups, right? So lower RPO, so our recovery period object would be less, obviously, because the more backups we take, the less is the RPO along with the transaction log files. And also the encrypted backup stream. Natively Postgres does not uh, does not provide any encryption at any level. Like suppose you are storing some data on the disk, right? That is not encrypted by default. So for this you can use there are some third party tools available like PG Backers, Barman. So using those you can encrypt the backups, and also the cloud providers such as Azure Postgres, RDS, and the Cloud SQL. Out there the backups are encrypted by default. Okay, and also like so if you are using on-prem Postgres, right, you can encrypt the disk so that your backups are safe. Okay. So this is the timeline of the features introduced between 17 and the 24. So this is like a recap. I said like in 2017, Postgres 10 Scram SHA 256 is introduced, and 2018 LDAP powered SSL, 2019 GSS API, and 20 there is a valid until clause is introduced under create user. 2021 there are some SSL enhancements happened in 21, and as like the important thing in Postgres 15, so there is a public schema permissions got revoked, and also the column level security got introduced in Postgres 15, and at last and in 17 there's a direct TLS handshake and the incremental backup features are introduced. So, like whenever, so I would like to conclude by saying that whenever any feature is introduced in the lesser version, that feature is also available for all the next consecutive versions. For example, here, Scram SHA 256, it is introduced in version 10. So, one should assume that it is available in all the next successive versions. So, yeah, that's all from my side for today. Any questions? I could not hear, sorry. I could not able to hear. Yeah. LDAP, right? LDAP, I think you should use the plain one only. Yeah, that is the only one. But if you are using, suppose you are using PG Bouncer as the connection polar, right? So you should use either a plain text or the MD5 authentication mechanism, because there is no support. Scram can't support the PG Bouncer. So PG Bouncer is like a connection polar between your client and server, right? So from client to PG Bouncer, the authentication can happen through Scram. However, from PG Bouncer to server, Scram can't support it. So how you should follow? Like you need to use MD5 passwords for PG Bouncer, and for the direct database authentications, use the Scram authentication. Any other questions? Okay. I think in Postgres terminology they call it as Scram SHA 256. That's what my understanding is. I think both are same only. Like so, you do it manually or you configure it using some. So you do it manually, right? I am also not sure. Yeah.
Uh,
So
Pulsit, Shiva here.
I have
One doubt. So you have a password encryption parameter, and there is another the authentication method in the HBA file, right? Host-based authentication file. So if you have MD5 set up in your HBA file and you change your password encryption to Scram, does it impact your connections or does it need
Yes,
any
it
fixing?
does impact. It won't support, right? So host-based authentication is nothing but like it validates that particular client from some IP, right? Usually the client request comes from some IP, and you whitelist that subnet or IP in the HBA file, right? Obviously, like if the password is stored in a different format other than the one mentioned in PGHBA, it is going to reject it for sure.
Thank you.
So we have the sponsor talk from Shreya at 5 o'clock, who is also from Microsoft. And also, like I would like to talk about the POSET. So it's a open source virtual conference organized by the Microsoft. So this is a open conference. So you can scan this code and like you can type on internet also. Just type POSET. Like we have the conference which is organized every year. So this year also the POSET happened. So there are some good amount of Postgres videos uploaded on the YouTube. Like you can explore, you can go through those videos. Yeah, thank you.